Yes. Now I think you already know what the path looks like, right? Okay, in projectile motion. Yes or no?
Sir?
I'm sure that you already know how the path of projectile looks like.
Yeah, it's parabola.
Parabola, right?
Yeah.
Um, let's try to understand that in detail. See, what is basically projectile? You throw something from one x position, one horizontal position, it lands down to something, some other horizontal position. It might have a vertical displacement, it might not have a vertical displacement. If it has, it does. If it does not have a vertical displacement, it is called ground to ground projectile, right? That it starts from ground and ends up at ground, or it is simply called on a plane projectile. Why? Because the level that it started and the level that it ended is basically on the same horizontal line, right? The level is same, right?
Yeah.
It might have a complex case where you throw something like this and it lands on some height or something, let's say on a rooftop of a building or something. This is also like a complex case. What is the difference between these two cases? The only difference is in one case you have vertical displacement, clearly you can see, right?
Yeah.
This is your net displacement vector. So this will have two components. This is a horizontal component, this is a vertical component. So it clearly has a vertical displacement. But when your net displacement vector is something like this, then clearly the vertical component is 0. Right? Okay.
Yeah.
So now our task is to understand how do we basically apply all the existing SUAT equations. Remember SUAT equations?
Yeah.
Can you tell me?
V equals U plus U plus AT. Yeah.
And
And then S equal to UT plus half AT square,
and
and S equal to VT minus half AT square.
V square equal to U square plus 2s.
Oh, because that other VT minus half AT was also there in the book actually.
Vt minus half at square.
Yeah.
That is also fine, but it's like a clear variation of this. I'll tell you why these equations are more than sufficient. We don't need anything else. If it's there in your textbook, well and good. Okay, fine. First of all, why the equations are written like this? Let's try to understand that. See, how many letters I can see here? I can clearly see the initial velocity, a final velocity, acceleration, displacement, time. Right?
Yeah.
You might know that these equations are valid for constant acceleration. Do you know this or not?
Yes, sir.
Only when acceleration is constant we say these equations are true. When acceleration is not constant, this equation automatically becomes false. You know this?
Oh.
Yes. These are only valid for constant acceleration, which is why all the question that you would have done, you took, let's say you took like a vertical acceleration, you would have taken gravitational acceleration 9.8, right? 9.81, 9.8, whatever they say, right? Or if they say air resistance also, that will also have a constant horizontal acceleration, but still it is constant. It is not changing with respect to time. Okay.
Yeah.
When you study like an advanced course in calculus or something, you'll realize that only when a is constant, you try to write a as a constant function. Just think like this. If you remember calculus differentiation for about. Okay. So when you say that a is a constant function, obviously the integration of a, which is velocity, will come like a linear function. See, it's clearly a linear function in t, and then this will come a linear function. The integration will be 1 power more. That means it will be a quadratic function, t square.
Yeah.
Right? Which is why this equation is written like this. Of course, we eliminate t from here, you get this. So third equation is not a reference equation.
T is the variable.
Yes, t is a variable. Okay, this becomes constant. Okay, because it's clearly a constant. We started the premise from right. This is also some kind of given data because when the particle starts its motion, u is basically telling us what would be the velocity value when it started its motion. So since it's like a given data, that will not change. Because the question that comes is, see, always try to understand why we study that particular concept. Every concept starts from a question. What is the question? The question is, what is the velocity value v and displacement value s at time t? This is a question that is getting asked, which is why these are the answers of that question.
Oh.
Understood?
Yeah.
try to write velocity as a function of time. See, we have written velocity as a function of time. We have written displacement as a function of time. But what if time is not given? Then this.
Yeah.
Somehow elimination of time will give us this. But still, the fundamental question remains same. So because these two are in some way constant quantities, given quantities and constant quantities, now how many other letters are left? V is left, S is left, T is left. Now these three are changing quantities. You can either say them changing quantities, you can either say them unknown quantities, or you can either say them dependent quantities. They depend on time. See, V and S depend on time. Understood?
Yes.
Now, because we write V and S as dependent on time, which is why the equations are written like this. See, V, S, and T. Now, to get a unique value, what do you mean by unique value? I'll take an example. Let's say the final velocity is some 15 meters per second. The displacement is some 25 meters, and time is some, let's say, some 2 seconds or something. Okay. Now, the problem here is, if this format is not written, you would get 15 meter per second velocity, 25, and let's say U and A are also fixed. Listen to me, I'm trying to go in a little bit depth. I'm saying you fix V, you fix S, you fix U, you fix A, you will automatically fix T. You will not get two different times where you get these set of particular values. If you get like, instead of 2 seconds, if you get 3 seconds, then any one of the value will get compromised. So to get a unique set of solution, we write it like this. Why does it become unique? Because if you look carefully, here there is no S. Here there is no V. And here there is no T. See? Writing like this gives us a unique set of solution. This has V and T present. This has S and T present. And this has V and S present. This gives us a unique solution of V, S, and T. That means fixing V and S will automatically fix T. Fixing S and T will automatically fix V. Fixing V and T will automatically fix S. Which is why this format. Understood?
Yes, sir.
This is the reason that we write this equation like this. And of course, if you arrange the letters in a particular way, which is why we call it SUVAT equation, right? Because it is SUVAT. You can also call it Vastu. You can also call it Utsav. There are many versions to it, but forgetting all the jokes. Right. My point is very simple. We have these 5 letters, we have to form this equation, 3 equations. Because you have studied maths, you know this, that if we have 5 letters, we need at least 5 equations, right?
Yeah.
But we are only satisfied with 3 equations. Why not 5? This is the reason. Because the other 3s are not, the other 2s are not unknowns, they are fixed. Got my point?
Yes, sir.
Okay, fine. Now coming back to projectile. Now, what is the relevance of this SUVAT equation with projectile? Very simple relevance. Projectile has 2 axes, x-axis, y-axis. It will have an initial velocity in x. It will have an initial velocity in y. It will have a final velocity in x. It will have a final velocity in y. It will have acceleration in x, acceleration in y, displacement in x, displacement in y. Time does not have xy quantity. Time is same for both. Now, whenever you have to solve projectile questions, always remember, just apply these equations here and these set of variables. I mean, these letters here and these letters here. You will get 2 sets of 3 equations. What do you mean by this? I'll write it. See, velocity in x is equal to initial velocity in x plus ax into t. Displacement in x is initial velocity in x time plus half acceleration in x times t square. And final velocity square, x square, is initial velocity x square plus ax fx. Same thing can be replicated in y, which means velocity in y is initial velocity in y plus acceleration in y times t. Displacement in y is initial velocity y times t plus half acceleration in y times t square. And velocity in y square is displacement in y square plus 2 times of acceleration in y times displacement. We can apply these 3 set of equations independently on both the axes. Why independently? Fortunately, first thing, because these letters are all vector quantities. You know, there is a thing called in vectors called resolution. Resolution means what? Splitting. You split the basically vector in two different axes, x-axis and y-axis. So whatever it happens in x-axis, it won't affect anything in y-axis, and vice versa. Whatever happens in y-axis, it won't affect anything in x-axis. Which is why we can solve this independent equation together. Understood? Now,
Yes.
how does this relate? How are these two related? Clearly, you can see, remember I told you, time does not have an x-axis and y-axis. So time is that common linkage between these three set of equations and these three set of equations. See, time is t. T is not tx, ty. So, for example, let me take like a very worst case. Let's say the particle is somewhere here. It's midair. We know that displacement vector is here. That displacement will definitely have two components, horizontal component and vertical component. Correct?
Yeah.
Now the thing is, horizontal component is x-axis, vertical component is sy. And right now, let's say the velocity here is some v value. That v value will also have two components, vx and vy. In this case, mostly if air resistance is ignored, the only acceleration that we have is acceleration due to gravity g. You can clearly see g is only vertical. It does not have any horizontal component. Which is why in most of the cases we take acceleration in x-axis as 0.
Yeah, because speed will be constant, right?
Speed in x-axis does not change. Y-axis
Yeah.
definitely changes. Understood?
Yeah, because at the top, like at the peak of the parabola, the like the velocity is zero, right? We have velocity of y, the vertical
Velocity,
component is zero.
exactly. At the topmost point. Yeah, at topmost point, because just think, let's say you have two eyes at two different places, not next to each other. Let's say one eye keep here, keep your one eye here. You can clearly see what the particle will feel like. The particle won't feel like going like a parabolic path. It will feel like it went up and it came down. Right? If you look it from here.
Yeah.
And if you look it from here, let's say you keep your one eyes here, it will feel like it went into a straight line. Nothing else.
Yeah.
Because the eyes, if one eye is there, it won't be able to feel the depth. So
Yeah.
depth here is this one, which is why it won't be able to feel this, which is why it will only feel this, going up and down. And of course, the eyes is here, so depth is here, so which is why it won't feel this, it won't only feel this. Right, so one eyes will completely visualize your x motion, that is your eyes up, and one eye will completely visualize y motion. So with respect to that y motion eye, with respect to this one, what is happening? That particle is simply going up and coming down.
Yeah.
So obviously, when it went up and came down at the topmost point, that velocity would have become 0. Right? Okay.
Yeah.
And of course, for the particle that it went in straight line, there is no acceleration at all, which is why for this eye, it will feel like a straight line, constant, uniform velocity motion. And for this eye, it will feel like a accelerated motion up and down when you throw something up and down. Okay.
Yes.
Now,
Yes.
of course, with the help of angles and all, you'll be able to simply relate the quantities. You can write, let's say the initial velocity is x, so you can write this velocity component as u cos theta, this velocity component as u sin theta. I think you know all this, right?
Yeah.
Right. So you can clearly see that the initial velocity is x component is u cos theta, initial velocity is y component is u sin theta. Right?
Yes, sir.
Okay, fine. Let's do like a complex question here. If you want to write, you can write this.
I'll
Whatever.
take a screenshot. I'll take a screenshot because
Ah,
it will be more
you can
useful
take
for
a
me.
screenshot. That is also good.
Yeah. Done.
Now, let's do like a complex question. Let's say you throw something like this, let's say with the speed of, I'll take, let's say 10 meters per second, and let's say the angle is some 60 degrees. Okay.
Yeah.
It will definitely go like this.
Yeah.
We have to find how much, and of course, assuming the G value is, I'll not take 9.8 for simplicity of calculation, I'll take 10.
Okay.
Okay.
Yeah.
We have to find what is the distance that this travels, the horizontal distance. It is called as range. What is the value? Second, we have to find what is the maximum height that it has.
Okay.
Can you try or should I try?
One minute, sir. So we have to find the distance it travels horizontally and like the maximum height vertical.
Maximum.
Right. Okay.
And yes, air resistance is zero. No air resistance.
So vertical component will be v sine theta or like u sine theta, which is 10 into sine 60.
Hmm.
Okay. And horizontal will be 10 into cos 60.
Correct.
Okay. For maximum height, uh, I can assume that the initial velocity, the initial velocity is u sine theta, right?
Yeah. 10
But
cents. 60.
so at the top of the arc, at the top of the like at maximum height, velocity will be zero.
Yes. Y axis velocity will be zero, not x.
Yeah. So I can take acceleration as 10 meter per second square.
Hmm. Yeah.
So it'll be 10 equal to 0 minus 10 sine 60. Okay. Uh,
Give me the final answer. Solve it on your own. Let me see.
yeah, but time will only be one, right? Because it's like traveling at 10. Oh, I don't have the time. Hmm.
Time. You can find. How do you find
Oh
time?
yeah, oh yeah, yeah, I can find 10. And that's what I was trying to find in the first place anyway. Never mind. I
Always
missed it.
remember, Suraj, these three equations. S equal to ut half at square, v equal to u plus at, and v square equal to u square plus t. These three equations should always be at the back of your head.
Oh,
Yes. So when you look for
oh,
y
then
axis,
that's easy. Then that's easy. So 0 equal to what is this? 10 sine 60 plus 10t.
no, minus 10. You know why? Because it's vertically
Up.
down.
Yeah, my.
Acceleration is down, initial velocity is up.
Mm,
Always follow the convention, Cartesian convention, which is right side plus left side minus up plus right minus down minus. Always follow this convention. So any quantity which is down, for that you'll take minus. Any quantity which is to the left, for that you'll take minus. Any quantity which is up and right, for that you'll take plus. So clearly acceleration is down, which is
yeah,
why
so it's
v
in
is 10.
minus.
Initial velocity is up, which is why plus. And
Okay,
final
so actually, so time is 0.3048 seconds. Okay. So maximum height will be oh my, it's equal to ut plus half at square.
yeah, you can apply that.
But I don't need to do that. I can just do v like v equal to s over t. I can use that formula to find.
V equal to S over T is valid when acceleration is zero, not constant. Here
Okay, then
acceleration
after
is zero.
yeah, so 10 sine 60 into 0.3048 plus half into minus 10 into 0.3048 whole square. Okay, let me calculate this. Uh, so 10 sine 60 is 0.3048 plus half into minus 10 into 0.3048 plus. The displacement
Hmm.
is minus 1.39 meters. Since I took acceleration as negative. If I take acceleration as 10 meter per second square, it'll be 1.39 meter
What?
maximum
Displacement,
height.
maximum height.
Yeah.
Fine. Find everything. Find maximum height, find range, time.
Okay. Mm. The horizontal acceleration is zero. Okay.
Yes. Okay, fine. Stop right there. I'll try to approach this from a very like a novice student. Okay. What data is present with me first of all? Let's try to collect that data. See. Hmm. I have initial velocity in x. I have initial velocity in y. I know acceleration in x-axis is 0, so that also I have in a way. I have acceleration in y as negative 10 meters per second square. Okay. I want to find d, and I don't have time, right?
Yeah.
What I want to find displacement in x, total displacement in x, right? Because when the particle lands here, this is a total displacement in x, right?
Yeah.
That is range, right? And for maximum height, I'll do something. Now I can clearly see that maximum height is when the particle is midway. That means the particle's half journey is completed. So now, if you look at from a perspective of y-axis, you can clearly see there is an acceleration. So I cannot write v is equal to s by t. But what if you look at from x-axis perspective? X-axis does not have acceleration. Its acceleration
Yeah.
is 0. So for
So
that,
v square equal to u square.
yes. So v and u will always be same in x,
Yeah.
not in y. So what would happen here is, I can clearly say that Vx is equal to Ux is equal to Sx by, let's say I'll take the total time as capital T. You know why? Because here the acceleration is 0. So here
Yeah.
applying velocity is equal to distance over time is perfectly okay. Nothing wrong.
Okay.
Right?
Yeah.
Okay. Now the only thing is that we need to find capital T for finding Sx. If we somehow get capital T, that is the total time it took for the entire journey, we can clearly find Sx. We already know Ux. Now, how do you get capital T? We can clearly say that since this was capital T, this would be capital T by 2, half the journey in x-axis.
Yeah.
For this, I cannot say that half the journey will take half the time. But in x-axis, I can definitely say it, right? Why not? Because in x-axis, there is no acceleration. So x-axis is like a uniform motion. Half the journey, half time. 3/4 of journey, 3/4 of time. 60% of journey, 60% of time. Right? Okay.
Yeah.
So clearly, I know that when the displacement in x becomes half, time would have also become half. So I know the time. Now I know the relation of time of y and time of x. What is it? Whenever the particle reaches maximum height, that is only possible at t by 2. Because t is a total, capital T is a total time. So for half the time, the
Oh.
particle would have been at maximum height.
Okay, so now you can find t by 2 by doing s equal to, sorry, by doing v equal to u
Apply
plus
anything
at.
here, exactly. Now you can
Yeah.
apply anything here to find t by 2. Once t by 2 is found, everything is found. How do you do it? Let's pick the first simple equation, v equal to
Yeah.
u plus at. Let's do this.
0 equal to,
Equal to uy plus ay into t. Vy is clearly 0. Uy is clearly 10 sine 60 plus 10 sine 60 because it's 10 sine 60 up.
yeah.
Ay is clearly minus 10. And what is small t now? It is capital T by 2. Is that
Yeah. Okay.
right? From here, we
Yeah.
directly get the entire journey time. What is it? 10 into sine 60 is root 3 over 2. And minus 10t by 2 is 5t. So 0. So which is why 5t is equal to 10 root 3 by 2. Which is why what is t? It is 2. 10 root 3 by
0.60610.
10, which is root 3. I'll simply write root 3. I'll substitute root 3 later. Right? Because 5 times 2 is 10 and this 2 will get cancelled. So t is directly root 3 seconds. This is the entire journey time. Entire journey. Right?
Yeah.
The entire journey got completed in root 3 seconds. Now, for finding range, what I can say, it is nothing but the total displacement in x-axis, which is nothing but initial velocity or final velocity or whatever you want to say, times total journey time, because acceleration is anyway 0. Or just think like this. You apply this equation, Sx is equal to ux into t plus half ax t square. Just what would happen to this equation when ax becomes 0? This entire term will become 0. Sx is simply
Yeah.
ux into t. That also is fine. So you can apply
So I have
square.
a doubt. How do you get t, like capital T equal to 3 seconds?
Solve this equation, a basic algebra equation. 5t equal to 10 root 3 by 2. I'll solve it. See, 5t is equal to 10 root 3 by 2. T is equal to 10 root 3 by 5 into 2. Now 5 into 2 is 10. 10 and 10 will get cancelled. T is equal to root 3. Right?
Yeah.
Okay. Fine. Now, We know the total journey time. We have to find horizontal range. What is range? It is nothing but initial velocity. What is initial velocity? 10 cos
Oh
60.
gosh, yeah.
10 cos 60 times total time is root 3. So what is the answer? 10 cos 60 is half root 3. This is 5 root 3. Right?
Okay.
Here? Okay.
Yeah.
This is total displacement in x. Right? First part is
Yes,
done.
sir.
Right? This part is done. Right? Now you have to find maximum height. How do you find maximum height? Okay. Let me go one more level. Let's say I don't have any idea about t by 2. I know what is the total time taken here, so I can clearly apply this equation and get the answer. But what if I don't want to use that? Then use this. Because what is the only equation that does not have t? Third equation.
Yeah.
Rest two both the equations have t now.
Yes.
Right. So let's apply third equation directly. V square is equal to u square plus 2as. Now vy square, uy square, ay, sy, because we are applying in y. Right? Final velocity is clearly 0. Initial velocity, what is the value of initial velocity? 10
And
sine
sin
60.
60.
Right? So this
Yeah.
is 10 sine 60 whole square plus 2 ay. What is ay? Minus 10, right? We
Yes.
already discussed this. Sy we have to find, which is capital, which is height, maximum height. Right? 10 sine 60 square is what? 100 into sine square 60, which is root 3 by 2 square, which is 3 by 4. Correct?
Mm.
10 sine 60. 10 sine 60 is root 3 by 2 square. 10 square is 100. 3 by 2 square, root 3 by 2 square is 3 by 4. Okay, fine.
Yeah.
Next, 2 into 10 is 20 minus 20h. And this is clearly 0 here. This 20h will clearly go on the other side. This will become 20h is equal to 100 into 3 by 4.
15 by 4.
H is equal to 15 by 4, which is how much? 3.75.
7 side. Yeah.
This is height. If you don't want to find this way, you already have time. You can apply Sy is equal to Uy into T plus half Ay T square. Now we know that Sy you have to find, which is capital H. What is Uy? Uy is 10 sine 60, right?
Yeah.
Let's apply that. So 10 sine 60 times T. Well, now what is the time taken for maximum height? Half time, right?
Yeah.
Now what is the total time? Root 3. So what is half time? Root 3 by 2. Right? Here
Yes, sir.
plus half. Ay. What is Ay? It's clearly negative 10 times root 3 by 2 square. What is it? It will come basically the same answer. 10 into sine 60 is root 3 by 2. This is also root 3 by 2. Half 10 times minus 10 into half is minus 5 into root 3 by 2 square is 3 by 4. So this becomes what? 10 into 3 by 4 minus 5 into 3 by 4, which is 3 by 4 is common. 10 minus 5 is 5 into 3 by 4. Same
15
15
by
by
4.
4.
3.75. Yeah.
Answer will not change. At the end, it's maths, no?
Yeah.
Maths can give you same answer by two different methods. These are just two equations. And remember, I told you, you will get a unique solution. No matter which path you go. You go this path, either you apply time, you use time equation and you apply second equation, second kinematic equation, or you don't apply and you don't use t, that is time, and you apply third kinematic equation, you would end up at the same value. I hope this is understood.
Yes,
I
sir.
intentionally took this question. This is like a tough level question. Okay, fine. Now I
Yeah.
want
Just 1 minute. I'll just change your light 1 minute.
you.
Yes, sir.
Yeah, hope you have understood this.
Yes, sir.
Okay. Note it down, write it down. I wanted to write it down.
Yes, sir. Yeah, sir.
Done. All right, perfect. Shall I give you a question to try? Will you try?
Sure, sure.
I'll give you like a different question. We have a building of height 80 meters, no air resistance, okay?
Mm.
We throw a particle at an angle of 30 degrees with a speed of 20 meters per second. Obviously, it will go something like this. You have to find where it lands from the foot of the building, this d distance value,
Okay.
and how much time it takes to land. Now, this is a parabolic path, but this is not a case of ground to ground because the level on which it lands and the level from which it started, it's clearly at two different heights. Right?
Mm.
Okay. Right?
Yes, sir. 20 meter per second with the light speed.
How much time you want for this?
Can you hear me?
How much time you want for this?
Uh, 3 to 4 minutes.
Fine. I'll give you
I'm just
5.
supposed to find the horizontal distance, right?
Yes, you have to find this distance and time.
Yeah. Okay.
Time of total journey.
Yes, sir.
Okay. Right? I'll just bring water, okay?
Yes, sir. Mhm. Okay.
Hope you're done.
Ah, I'm also.
I'll tell you where you'll be stuck here. The only problem that you might face is writing final horizontal displacement and final vertical displacement. That is final displacement in X and final displacement in Y. If you can crack that, then there is nothing else in this.
Final displacement in Y I got is 85 like 5 meters. Sir.
Final displacement in Y is what?
Oh no, no. Oh, okay, okay. Hold on.
Displacement. Remember, so what did I tell you? Displacement is the shortest path from initial to final position. So displacement will have two components. One which is this that you have to find in X, and one which is already given
80.
in Y. So what will take displacement in Y?
0. Wait, 88 minus 80.
Minus 80. Correct. Remember why? Because down minus, up plus, right
Plus.
plus, left minus, the Cartesian coordinate system. So you can clearly see that displacement in Y is negative. Minus 80. It's down. So now when you apply the equation, put Sy as minus 80 everywhere, wherever you get.
Yeah. Mhm. Yeah, I'm not sure, sir.
Let's see. Sy is equal to Uy into T plus half Ay T square. Right? Let's apply.
Yeah.
Sy is negative 80. What is Uy?
20 sine 30
20 sine 30 plus or minus?
minus 20 sine 30. No,
Yes.
let's.
See, initial velocity is up. Plus 20 sine 30. Okay.
Yeah.
Plus 20 sine 30. Time is, of course, unknown. Let it be T. Half. What is Ay?
Minus 10.
Minus 10. T square. This becomes what? Minus 80 is equal to 20. Sine 30 is half. T by T square. Minus 80 is equal to 10T minus 5T square. Clearly, it's getting cancelled by 5. minus 16 is equal to 2t minus t square. T square minus 2t minus 16 is equal to 0. This is what a quadratic equation. T, use a calculator, right?
Yes, sir. 9 minus 2 minus 16. 1 plus or minus root 17. But it should be 1 plus root 17.
Exactly. 1 plus root 17 would be accepted. You can also apply minus b plus minus b square minus 2ac minus 2 into minus 4 into 60, 64 divided by 2. So this is 2 plus minus root 68 by 2. Root 68 is 17 into 4 is 68. So 2 plus minus 2 root 17 by 2. So 1 plus minus root 17. 1 minus root 17 is rejected. 1 plus root 17 is accepted. Right? Why? Because time cannot be negative. You cannot go in past. Right? So 1 plus root 17 is acceptable time. Okay, perfect. That's it. This was the first thing that I asked. Right? You have to find capital D. How do you find capital D? It is nothing but horizontal displacement x. It is what? Ux into t plus half ax t square is anyway 0. Ignore it. Right?
Yeah.
I'll write it here. I'll write it and then I make it 0. Half ax t square. Sx is asked. Ux is what? What is the value of ux?
20
20
cos 30.
cos 30. Okay. So 20 cos 30 is root 3 by 2. T. What is t? 1 plus root
Root
70.
17.
Half ax, that entire thing is 0. Forget about this. 10 root 3 into 1 plus root 17. Now put it in calculator, get the answer. That's it. Whatever is the answer, we'll calculate that. Fine, nice.
Mm.
Okay.
Yes, sir.
What? 4, 5, 5 into
10
1.7.
root 51 plus 10 root 3.
1.7 into 317. 17 into 5, something 85 or something between 85 and 90 is the answer.
Yeah, 88.7, sir.
88.7. I told you. Because 10 root 3 is what? Root 3 is 1.7, 10 into 1.7 is 17. And root 16 is 4, right? So root 17 is something just more than 4. You add 1, it will become just more than 5. So 5 into 17 is 85, so answer will be just more than 85. 88. Right?
Yes.
Why I'm saying like this? Because even if you, let's say your calculator, some typing error you did in calculator, in MCQs you can just tick the option, because not every option will be between 85 and 90. Some might be more than 90, some will be less than 70 or right.
Yeah.
This is like even a guesswork should be calculated. Is what I'm saying.
Okay. Yes,
Got it?
sir.
Okay, fine.
Yes, sir.
Let's solve. I think one more tough question.
Yes,
And
sir.
now let's not use numbers. We'll simply use letters. Okay. I'll
Okay.
give you a question from an author's book. Wait, just give me a moment. Hmm, Guys, is it visible or should I zoom it in?
Can you zoom in a bit more, sir?
I'll zoom it. Is it fine now?
Yes, sir.
Right.
In the speed of projection of the stone. Root will be much. Oh, okay. The angle at which it strikes the roof of the building is half of the angle at which it is
That will not make
projected.
a difference. What you have to do here is, I'll tell you the method also. See, assume write the initial velocity as u or something,
Yeah,
final velocity as some v or something. See, don't you think if this angle is 30 degree, this angle will also be 30 degree?
yeah,
So the strike is something like this, that the final velocity is, sorry, this will be v, this angle is 30 degrees. So you can clearly see that this component will be what? Horizontal component, v cos 30, right?
yeah.
And vertical component is what? V sin 30, correct? Now
Yes.
we know that initial velocity horizontal component is what? U cos 60, and vertical component is what? U sin 60. Right? And remember, I told you in acceleration in x-axis 0. So horizontal component velocity will not change. So I can see that u cos 60 and v cos 30 are basically same.
Yeah.
So this is the first relation that you will get, right?
Yes, sir.
U cos 60. Sorry. U. This is not, yeah. U cos 60. Wait. U cos 60 is equal to V cos 30, right?
Yeah.
U cos 60 is half, V cos 30 is root 3, right?
Exactly.
So U is equal to root 3 V. This is the first relation, right?
Yes, sir.
What is the second relation? We know for the fact that the final vertical displacement is what? See, the displacement vector is something like this. I'll draw it with red. What is the final vertical distance? Don't you think it is h?
Yeah, it's H.
We can directly apply the equation. Vy square is equal to uy square plus 2ay sy. You know why? Because final velocity is y component is v sin 30. In fact, negative v sin 30. Correct?
How so?
Because final velocity in y axis is what? This one.
Yeah.
So that's why negative v sin 30 minus.
Because it's going down.
What is initial velocity is y component? It is u sin 60.
Yeah.
Right? What is acceleration in y? It is negative 10. And what is displacement in y? It is positive h. Right?
Yes, sir.
Got it? Okay. Now, what they have asked, then the speed of the projection of the stone. They have asked u, which is you have to eliminate v. We already know the relation between u and v. Just eliminate it. What is v? It is u by root 3. Right? Just put here. This becomes what? V square sine square 30 is equal to u square sine square 60 minus 20h. V square, v is what? U by root 3, so it will become u square
U
by
square by 3.
sine square 30 is 1 by 2. U square, sine square 60 is 3 by 4 minus 20h. Right, so this becomes what? U square by 6 is equal to 3u square by 4 minus, not, I'll not write 20h, I'll write 2gh. You know why? Because the answer, look at the option, the answer in form of g. So they have not substituted g, which is why I'll write simply g here. I'll not write minus 10, I'll write minus g. Okay.
Yeah.
Minus 2gh. Okay, so minus 2gh, which is why 2gh, now simple algebra. 2gh will go on left side, u square by 6 will go on right side, 3u square by 4 minus u square by 6. What is the LCM of 4 and 6? 12.
Yeah.
Okay. So 6 times 2 is 12, 4 times 3 is 12. Right, so 2gh is equal to 3u square into 3 is 9u
square.
3 into 3 is 9 and minus 2.
7u square. Yeah.
Wait, have I done something wrong here?
No, 9u square by 12 minus 2u square by 12, right?
Wait. I've done something wrong here. Wait. Sine square 60. Oh, sine
You
square
forgot to
30.
square it.
Yeah, 1 by 4. Sorry, my bad. 1 by 4, 1 by 4. So this is 3u square by 4 minus u square not by 6. It is u square by
12.
12. One mistake and you enter wrong clips even. That's mistake. So this is what 2gh is equal to 3u square by 4 minus u square by 12 times 3 times 3. 3u square into 3 is 9u square minus u square is 8u square by 12 is equal to 2gh. So 2gh is equal to 4 times 2 is 8. 4 times 3 is 12. U square is equal to 3 into 2, 6. 6 by 2, 3. Right? U square is equal to 3gh. U is root 3gh. Okay?
Yes.
Option C. Got it?
Yes, sir.
Okay, fine. Noted.
Yeah.
I think we'll not be able to do waves today.
It's fine, sir. I'll publish more of this and I'll like study waves as well. So if I have any further doubt in waves, I'll come to you business first.
Sorry?
Like I'll do more questions in this chapter and
Yes.
more, and I'll study waves as well. So if I have any doubts in waves, I'll like come to you
Yeah.
with my doubts in the next class. Or like I think the next class I'll have finished around 6 paper 2 papers. So I'll have doubts in that also.
Yeah. Okay. No dispatch.
Yes. So it's vy square equal to uy square plus 2ay sy, right?
Yeah, it's not SY square. Sorry, yeah. It's A by SY.
Um,
Done.
yes.
This part also.
Yes, sir.
All right, perfect. So I hope you have understood this class. How was it?
Yes, sir.
Was it good?
Yeah.
Definitely. Well then, do one thing. Next class, I expect you to solve that paper that you were saying and some more questions on this for practice. Plus, I want you to revise the concepts of it.
Okay.
That will make our job much more easier because we have only
Okay.
once a week, right?
Yes, sir.
Fine. Okay. All right then. Suraj, bye bye. See you.
Thank you, sir. Bye, sir.